right, now that we've taken a look at the different intermolecular forces that exist in different compounds, we get to look at how that affects the properties of these compounds. Let's start off with the first set of properties, which is melting and boiling point. So over here, I've drawn a picture of your sort of elementary school definition of solid, liquid, and gas, right? And you might have learned that in a solid, the particles are packed very close together. In a liquid, they're a little bit further apart, and then in the gas state, they're the furthest apart. So essentially what you have to do in order to go from a solid to a liquid and from a liquid to a gas is input it with energy. And the energy that's inputted is usually in the form of heat. But nonetheless, what it's supposed to do is break apart any of the forces that exist between the compounds, right? Or the molecules. And because those intermolecular forces are there, that's what kind of holds it together in the state that it's in. So imagine if you're going from a solid to a liquid, you are inputting it with enough energy to break apart those forces so that it can go on to the next state. There's a little bit more space in there, it becomes a liquid. And if you think about the type of compounds that have the strongest forces, that might make sense as to why our melting point and boiling points are the way that they are. So starting off, our ionic compounds tend to have pretty high melting and boiling points. So our ionic compounds have high melting and boiling points. And why is that, right? Think about it. Our electrostatic attractions, which is what keeps the ionic compounds together, those are broken apart, or those need to be broken apart in order for it to go into the next state, right? In order for it to become from a solid to a liquid. Our next level, right, are compounds that contain dipole-dipole forces and or hydrogen bonds. Those have intermediate melting and boiling points. Those are what we call polar compounds, right? In order for it to have dipole-dipole forces, it needs to have a dipole, and those only exist in polar compounds. So polar compounds have an intermediate melting and boiling point, right? So it's not as high as our ionic compounds, intermediate. I don't know how to spell, but so it has an intermediate melting and boiling point. And lastly, we've got our non-polar molecules. And these non-polar molecules only contain London dispersion forces. They only have the LDF forces that need to be broken apart. And because of that, they have pretty low melting and boiling points. Okay, moving on from melting and boiling points, we're going to take a look at solubility, whether or not different compounds are going to be soluble. So water is a good solvent because it is a polar molecule. And not only is it just a polar molecule, it is a polar molecule that is able to undergo hydrogen bonds as well, right? And because of these unique properties, water is an excellent solvent. And in terms of solubility, you can always follow the rule like dissolves like, right? And even if you remove water out of the equation, any solvent or any solute will dissolve in a solvent if it's like in polarity. So non-polar solutes will dissolve in non-polar solvents, and polar solutes will dissolve in polar solvents, right? So like dissolves like. So due to the polarity of water, ionic compounds, right, when you put it into water, they break apart into the ions, which are then able to form ion-dipole interactions with our water molecules, right? So there's that attraction that's possible, which allows for it to become soluble. Our polar covalent compounds, when they're entered into water, are able to form dipole-dipole interactions and thus result in dissolving to occur, right? So ionic and polar covalent compounds are soluble in water. Nonpolar compounds right? Those are insoluble in water, right? It's not able to form any other intermolecular forces other than LDF with the water molecules, right? And that's not strong enough for the dissolving process to occur. Right, so we've looked at melting point and boiling point as well as solubility. Now let's take a look at electrical conductivity, right? Electrical conductivity refers to whether or not electricity can pass through this particular substance, right? So ions usually must be dissolved to conduct an electrical current, right? Why is that the case? Because then they're going to have a charge, and that allows, so the positive ions and the negative electrons can form, or allows a path for those electrons to travel through. Only some compounds in the blank or dissolved state can conduct electricity, and the only ionic compounds, remember, because they're made up of ions, in the dissociated, which just means that they're broken apart into their ions. So the dissociated or dissolved state can conduct electricity. All right, so let's sort of summarize all of these properties into this chart. So the state at room temperature. Because ionic compounds have a very, very high melting and boiling point, that means that they are solid at room temperature, right? So at room temperature, that is not a high enough temperature for it to become a liquid or a gas, right? Nonpolar covalent compounds, on the other hand, their melting points and their boiling points are so low that by the time we get to room temperature, that they are a gas, right? So their melting points and their boiling points are very low that at around the room temperature mark, it is already a gas. Now, the polar covalent compounds, it depends on the compound. So they could be, some of them might be gas, some of them might be liquid, and others might be solid, right? So I'm going to put gas, liquid, or solid. Again, that depends on the situation, right? Electronegativity difference, we've already talked about that, right? Melting point, nonpolar covalent compounds have the lowest melting point, and this applies to the boiling point as well. Polar covalent has intermediate melting and boiling points, and ionic compounds have the highest melting and boiling points. Solubility in water, so ionic compounds are soluble, right? Because of the reasons that we talked about above. Polar covalent compounds are soluble. However, nonpolar covalent compounds are insoluble. Now, electrical conductivity in the solid state. Now, think about what electrical conductivity entails. It has to allow for electrons to travel through it. And because of this, you need ions present. And none of these different compounds in its solid state allow for electricity to pass through it. So I'm going to write here non-conductive. And that applies to this all. Now, electrical conductivity in the liquid state, both polar covalent and non-polar covalent compounds are both non-conductive. Right? Ionic compounds, if you're able to get it into the liquid state, there requires a very high temperature to do so because of the very high melting point. But if you're able to get it into the liquid state, it does conduct electricity. And ionic compounds, if it's dissolved into an aqueous solution, it does or it is conductive. And nonpolar covalent compounds, even if it's dissolved in an aqueous solution, is non-conductive. Okay, so that's a very brief summary of all of the different properties that we're going to talk about that have or are related to the intermolecular forces. All right.